Hello friends, this video on equilibrium part 43 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. Let's talk about a new topic called solubility equilibria. What is solubility equilibria? So if you must have observed, some of the ionic solids like calcium chloride, they are very much soluble in water. While some, for example, lithium fluoride, are almost insoluble. What is the reason? Why some of the ionic solids are soluble? Why some of them are not soluble? Right? So the solubility depends on the lattice enthalpy of the salt, the solvation enthalpy of the ions in the solution. These are the two factors on which the solubility depends. For example, if you see NaCl, the salt, it dissolves easily in water. Lithium fluoride doesn't dissolve in water. So for this to dissolve in water, if you want it, right? So the strong force of attraction between these Na and Cl or calcium chloride, it has to be overcome by ion solvent interaction. For example, the solvent is water here. So H plus this is minus partial negative charge, Na plus Cl minus. This attraction, Na plus Cl minus attraction, that's the lattice enthalpy attraction. This has to be broken by the ion solvent interaction. For example, H and Cl minus, Na and O minus. This interaction should overcome the lattice enthalpy interaction. Right? So in case of known non-polar solvent, the solvation enthalpy is small and hence not sufficient to overcome lattice enthalpy. So this is for polar solvent. If you see, a lot of things get dissolved. Non-polar solvent, they don't get dissolved because this factor is missing. Right? And the solubility also depends on the temperature. So example, you have water and you have put some sugar in this. You heat it, increase temperature, more and more sugar will be dissolved. Once saturated, if you cool down, you'll see that sugar crystals will come out. Right? So solubility also depends on temperature. So if you see, there's a category here. If the solubility is more than 0.1 m, we call that as soluble. If solubility is less than 0.1 m but greater than 0.01 m, we call it slightly soluble. And the solubility comes out to be less than 0.01 m, we say it's sparingly soluble, that is almost insoluble. So we'll take one example here. BaSO4, if you see, if the saturated solution becomes Ba plus and SO4 minus. If you put this in water, it gives barium ions and sulfate ions. So Ksp will be what? Nothing but concentration of this into concentration of this, and this is solid, so you can ignore that. So Ksp will be concentration of bariums into concentration of SO4 minus. Correct. So again, Ksp is again a fancy terms here. Nothing but the solubility product or solubility product constant, and the chart which has the solubility product for a lot of chemical compounds at a given temperature. So if you see silver bromide, the solubility product is 5.0 10 to the power minus 3. For calcium sulfate, it is 9.1 10 to the power minus 6. Just a table for reference. We'll take an example of solubility product. So we have to find the solubility product of A2X3 in pure water, assuming that neither kind of ions react with water. So I have A2X3, it will form 2A2 and 3X. So it will have charge 3 and X will have charge 2 minus. Correct? So let's assume that this guy at T is equal to 0 had X number of moles. And T is equal to equilibrium, S is soluble here, so this becomes 2S and 3S. So Ks is what? As I told, will be nothing but concentration of A3 square and X2 minus Q. Correct? This will be what? And this value is given 1.1 10 to the power minus 23. You put the values, this becomes A3 plus is what? 2S square and X2 minus is 3S cube. This is 1.1 10 to the power minus 23. You solve this, you get S as 10 to the power 5, 10 to the power minus 5 m. That is moles per liter. So you get F as 10 to the power minus 5 m. So with this we can see that it is less soluble. Right? So we have chart S has to be greater than 0.1 m, it is very soluble. Less than 0.1 m and greater than 0.01 m almost semi-soluble, and less than 0.01 m it's almost insoluble. So this is very, very less soluble. Right? The value of KSP of two sparingly salts, this and this, are given. So we have to say which salt is more soluble. So we have to say which salt is more soluble, we have to just find S. Correct? So let's suppose I have this reaction NiOH2, it will break into Ni2 plus and 2OH minus. Correct? So let's assume this is S1 is the solubility for this. So this will become, at equilibrium, this will become K or some X minus S1, this will become S1, this will become 2S2, 2S1. Correct? So you find the KSP, this is what? S1 into 2S1 square, right? Na plus concentration into OH minus concentration square. And this value is given 2 into 10 to the power minus 5. So if you solve the value, you get S1 as 5.8 10 to the power minus 5. This is what you get. Let's do for S2 now. The same other reaction is AgCN. It will give you Ag plus and Cn minus. So let's assume this was X and the solubility is S2 here. This becomes X minus S2, this becomes S2, and this becomes S2 itself. So KSP will be what? Concentration of Ag plus, that is S2, into Cn minus S2, and this value is 6 into 10 to the power minus 70. So you solve the value of S2, S2 comes out to be 7.8 10 to the power minus 9. So if you see, S1 is greater than S2, right? Since S1 is greater than S2, you can say that this guy is more soluble, right? So I can say that this is more soluble. Now we'll understand the common ion effects on solubility of the ionic solids. We have seen the ion effects in the reactions of in the hydrolysis. Now we'll see the ion effect in the solubility. Same thing here. If you increase the ion concentration of one ion, that ion will combine with the ion of opposite charge, and the salt will be precipitated till you get KSP is equal to QSP. Again, the equilibrium is disbalanced and it will try to reach equilibrium, right? We explained similar thing we have explained, right? So also if you increase the ion, if you decrease the ion, more salt will be dissolved, right? So it's very simple. If you increase the ions, salt will be precipitated out. If you decrease the ion, salt will be dissolved. For example, I'll tell you here. So if we have NaCl gives Na plus and Cl plus. So if we increase the ion of Na plus, what will happen? The stress of this will be overcome by forcing this reaction in this direction, right? Reverse direction. So NaCl will come out. If you increase, if you decrease the concentration of NaCl, the stress will be removed by forcing the equilibrium in this direction. That means more and more salt will be dissolved. And if you increase the Na plus, what will happen? The equilibrium will sit on the left hand side and NaCl will come out of the solution. Correct? Hope you understand this. See, if you increase this, equilibrium will move in this direction and NaCl will come out. If you decrease this, equation will move in this direction and more salt will be dissolved. Right? So if you take an example, so I have a saturated solution of NaCl and I pass HCl gas. So if I pass H plus HCl gas through it, then you see sodium chloride is precipitated. The NaCl is precipitated because the increased concentration of Cl minus ion. Because we are passing HCl, HCl is what? It will immediately break into H plus and Cl minus ion. So you are increasing the Cl minus ion here, right? You are adding more Cl minus ion. Since you are adding more Cl minus ion here, what will happen is the equilibrium will move in this direction and NaCl will come. Similarly here also, same thing. If you pass HCl gas here, since HCl gas will give you more Cl minus ions, Cl minus ion concentration increases, the equilibrium moves on the left side, AgCl is precipitated. Now you must be confused. We have discussed a lot of terms. We discussed K, we discussed Kw, we discussed Ka, Kb, Ksp. What are these terms? We discussed all this, right? So K was my normal solubility constant, equilibrium constant. Kw was nothing but my H plus ions and OH minus ion concentration. There is nothing but 10 to the power minus 14, right? Ka was the same thing for the acid. So if I have an acidic reaction and let's suppose I have HCl, it forms H plus and Cl minus, then Ka is nothing but my H plus concentration, Cl minus concentration by HCl concentration. Similarly, Kb was for base. Example, I have NaOH, it is in equilibrium, it's a dilute one, let's suppose, it breaks into Na plus and OH minus. So in that case, let's take a weak base actually. So let's take NH3, it dissolves in water, it gives NH4 plus and OH minus, right? This one you can say that Kb will be what? NH4 plus concentration, OH minus concentration by NH3 concentration. And Ksp is nothing but my solubility. So if I have, let's suppose, NaCl, it dissolves in water with Na plus and Cl minus. So Ksp is nothing but concentration of Na plus into concentration of Cl. All you got from K only, but they are different fancy terms. K8, Kw, Kb, Ksp. Right? Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.